All right, so this is the last video for the describing matter unit. If you have not watched the video on elements and compounds and the video on mixtures, please go back and watch those. Elements and compounds should be the first one, followed by mixtures. This video is dedicated to solutions, which is just a specific type of mixture. So if you haven't covered the mixtures video yet, you should definitely check that out first. So, all right, when we talk about creating solutions, we need to talk about dissolving, and this is just when the particles of a substance spread out evenly or relatively evenly throughout another material. And the particles that spread out are from, if something is capable of doing this, it's referred to as being soluble. So things that are soluble have, when we're talking about the situation of dissolving, you have a solute, which is the substance that is dissolved, and then you have the solvent, which is the substance in which the solute is dissolved. So to give kind of a specific example, if we're talking about like I don't know, making iced tea from a powdered mix, right? This is something that is fairly common. So the solute would be the powder, like the sugar and flavoring mix, that powder that you put into the water, and the solvent would be the water that you're dissolving the iced tea mix into. Water, by the way, is referred to as the universal solvent because it can dissolve tons and tons and tons of different materials. So it's commonly called the universal solvent. So the solute is what gets dissolved. The solvent is what the solute is dissolved into. Now, the solute, how much of it we have, determines the concentration of the solution. When there's a high concentration, it means that you have a lot of solute dissolved into the solvent. And when there is a low concentration, it means that there is a small amount of the solute dissolved into the solvent. So we can have various concentrations depending on how much of the solute we mix into the solvent. So it's really about that ratio. I can have two solutions with the same amount of solute that have different concentrations by having more solvent. So it is about that ratio, solute to solvent. If there's a lot of solute relative to the solvent, then it is a highly concentrated solution. And if there is a lower ratio of solute to solvent, so there's only a small amount of solute relative to the solvent, then we would say that the solution is diluted. So again, the concentration really comes down to the ratio of the solute to solvent. A lot is concentrated, a small amount is diluted. And this is why you might pick up a drink mix or something like that that is concentrated and you add water into it, or like they used to sell like cans of Campbell's soup that were concentrated. So you'd put 1 can of the soup and like 1 can of water combined in order to make the proper amount of soup, or the proper concentration of soup. On the other hand, sometimes things are diluted. So this would be, if you're picking up a mixture of, if you're that iced tea thing, you're making iced tea and it's too sweet, you would add in more water to dilute the solution. You'd add in more of the solvent to decrease the ratio of solute to solvent. So this all refers back to the concentration. This is one of the ways that we can discuss the ratio or the relation of solute to solvent. There's a whole different methodology of discussing it. This is really like a simplistic, there's a lot or there's a little bit sort of approach to solute versus solvent. Now, sometimes materials can't dissolve. They don't go through that process. So we refer to these as being insoluble. It's just some materials are not soluble in other materials. So when we talk about something being soluble, we say it's soluble in water, or it's soluble in oil. Other things would be insoluble. It's insoluble in water. It's insoluble in oil. So this always refer back to what would our solvent be. Soluble in a solvent, insoluble in a solvent. Now, here's where we get into a whole bunch of S words. I mean, we've already addressed a bunch. There's solute, solvent, soluble, but then we also add in solubility. This tells us the specific amount of solute that is needed to make a saturated solution at a certain temperature. So lots of S letters or S words and S sounds. So, well, what is a saturated solution? A saturated solution is a solution that contains the exact, precise maximum amount of solute that it can hold at a given temperature. So, assuming, if we're talking at room temperature, there's a maximum amount of salt that can be held in a glass of water. And if you try to dissolve more salt than that in, it's not going to. It's not going to be able to dissolve. It would just sit at the bottom of the glass. So there's a maximum amount. When you have that exact maximum amount, no more, no less, that's considered a saturated solution. It's a very, very precise amount. And the amount that's needed changes as the temperature of the solvent changes. Now, a solution that has less solute than a saturated solution is called an unsaturated solution. It's holding less solute than it could at a given temperature. So we could add in more solute and still have that solute dissolve. There's also a supersaturated solution. This is when more solute is being held than it normally would be able to at a given temperature. This happens if you heat something up and then dissolve your solute into the solvent and then let it cool. That solute that was mixed up is going to stay mixed up and stay held, but if you tried to make that same level of concentration without first increasing the temperature of the solvent, you wouldn't be able to. So these are called supersaturated solutions. This is sometimes done with those super sweet, extra sweet iced teas, where they heat the tea and then they add in sugar or corn syrup in order to sweeten the tea, and then they cool it. They would not be able to put that much sugar into the tea had they been trying to put the sugar in at a lower temperature. So this means that you can dissolve more of a solute in as temperature of the solvent increases. This is generally the case, almost always, but it's not perfect. So maybe 95% of the time, that as the temperature of the solvent increases, the more you could dissolve more solvent into that warmer temperature solute. Sorry, you could dissolve more solute into the higher temperature solvent than you could if the solvent was at a lower temperature. That's what I was trying to say. And then the last thing to talk about here are alloys. Alloys are solutions of metals or nonmetals that were dissolved into a metal. So the solvent itself has to be a metal. The solute could be a metal, it could be a nonmetal, it could be a metalloid, but the solvent must be a metal. An example of this is brass, where you take zinc, the metal zinc, and dissolve that into a different metal called copper. And that's what creates brass that are used to make trumpets and trombones and things like that. All right, that is the end of our elements, compounds, and mixtures notes. So you should be set and ready to go for the test. If there's things that you're confused about, shoot me an email or stop in and see me.